All right, guys. So we are starting the fingerprinting unit, which is pretty fun. I dress like a clown because today here is circus theme for homecoming, just so you know. We're going to be doing our own fingerprints here pretty soon. I doubt everyone has an ink kit at home, so I have been trying to think of some ways of how you can make some prints, and I actually have some pretty good examples. So I'm pretty sure there will be a way that you're going to have one of these items in your house to make your prints, and it's pretty fun to get to analyze your own prints. All right, so let's get started with fingerprinting notes. Here we go. So the study of fingerprints for identification purposes is known as dactylography or dactyloscopy. So that's dactyl means finger. So all of the whole identification purposes of fingerprints, all of it is called dactylography. So your fingers, toes, feet, palms, and lips are covered with small ridges that are raised portions of your skin arranged in connected units called dermal or friction ridges. So it's not just your fingers. You also have these prints on your toes. Like it says your feet, your palms, and even your lips are things we can actually match the patterns in a crime scene. Fingerprints are just usually the most characteristics and the ones we actually have on file for a lot of our suspects. So ridges help us grip objects. That's why they think that we have ridges at all. Like, why do we even grow these? Is scientists think is because it helps us hold on to objects. A ridge is what appears dark in the print, whereas the valley is what appears light. So the ridges are what pops up, and the valleys are what are laying down. Now, how we get our fingerprints. This is kind of like a little interesting science trivia here. Fingerprints begin forming during the 10th week of pregnancy. So when babies are about the size, looking like little aliens, about 3 inches long. And what happens is there's 3 layers in our skin. So here's a picture of the 3 layers of skin. There's the inner layer, the dermis, which is the thickest layer. So all this inner skin. And then there's the outer layer, which is the epidermis, which is like what you're touching. This is the epidermis. And then in between, right here, this little red squiggly part is called the basal layer. So why our fingerprints form at all is during the 10th week of pregnancy. In the fetus, the basal layer, so this middle layer of your skin, grows faster. That's it. It's growing faster than the bottom and the top layer. So the dermis and the epidermis, the basal layer is just growing faster. So being that it's trapped by the epidermis and the dermis and it has nowhere to go, but it's growing faster, it starts having to form these folds and intricate shapes because it's out of room. So literally, your fingerprints forming is just because the basal layer in the middle was growing too fast while you were developing as a fetus and was out of room, so it had to like crumple and turn. So the reason why our fingerprints are so unique is because that could happen in so many ways. Like there's no way to completely foretell how a person's going to develop their fingerprints when you're a fetus just with your basal layer growing faster. So that is what makes our fingerprints unique, is that process. So fingerprint residue originates from the glands in our, I can't say that word, subcutaneous skin, apocrine and eccrine glands. So basically those are your sweat glands. So when you're leaving fingerprints behind, you're technically leaving sweat prints, which is pretty gross. But that's what it is. We all sweat a little bit all the time on all of our skin. So anytime you're touching any surface, you're leaving a little bit of your sweat behind and leaving a print. So apocrine glands are associated with hair follicles, and eccrine glands are primarily located on the ridges of your hands and feet. So like the top of the ridge is sticking out is probably what's making more of the fingerprint, but all of them are a part of the sweat glands that make them. Weren't you clicking? All right. Now for fingerprint patterns. So this is what we're going to start learning how to identify and eventually get an identifying ourselves. 2 things a forensic examiner looks for on a fingerprint are the presence of cores and deltas. So a core is the center of a loop or a whorl. Okay, so if I'm looking at, it's not in arches, but in this loop or an arc is right here. So this would be the core, and then the whorl right here. So it's the very center of a loop or a whorl. And the triangular region located near a loop is called a delta. So see how this looks like a triangle and it's near the loop? That is called a delta. These are the easiest Patterns define your fingerprint because you're going to have one on almost every finger because there always is one delta if you have a loop shape, and there's always two deltas. So see, there's one here and one here. There's always two deltas for a whorl shape. So if you have that pretty whorl. Now, this is the percent of the population that has these fingerprint patterns. So 5% of people have an arc. So that is the most rare pattern to have. And then you have loops, which are 65%. So like me, I feel like I've already said this in notes, but I haven't. I'm going to say it again throughout the year. Pretty much everything that we learn in this class that breaks it down into like the percent of the population that has something, I am always the most average in every single category. So the most common fingerprint pattern is what all of my fingers are. I don't have any of the other patterns. I feel like even most people that I meet in class have at least one of the other patterns on one of their fingers, but I have all loops. And then the whorl is 30%, so a little more common, okay? Go forward. Now we have a couple different ways to break down the arches and loops and whorls, how they look a little different. So types of arches. The first one is just called a plain arch. Ridges enter on one side and enter on one side and exit on the other. So just up and down. And then you have a tented arc, which is just a little more spiky. So if I'm looking at this is like a, like a slope, a hill, a low mountain. And then the tented arc is like pointy mountain, okay? That's the difference. Now for types of loops, I'm really not going to focus too much on these, but I will talk about it a little bit and we'll practice a little bit. But basically it's just if they're entering from the right or the left side. So these patterns are named for their positions related to the radius and the ulna bones. So your radial loop, right thumb. So if I look at my right thumb and the loop opens towards the left. So if I'm having, and it's opening towards the left on my right hand. So if you're looking at your right hand and the loops are opening towards the left, then that's a radial loop. It's pointing towards your radius. Whereas if it's an ulnar loop, so I'm in the wrong hand. There we go. So I have my right thumb and it opens towards the right. So it's going this way, then it's pointing towards the ulna. So your ulna is by your thumb and your radius is over here. Okay. But mostly it's just like, read it. If it's opening to the left, but it's on your right hand, then that's a radial loop. If it's opening towards the right, but it's on the right hand, then it's the ulnar loop. Continue. Did I just get those backwards? I did. I was always like, I feel like I'm saying this wrong. I was. Your ulna is what is on this bone right here. So like you feel this little thing that's poking out? See how this in this picture has that little nubbin thing? Well, you can literally feel it right here. So this is your ulna bone going down here. And your radius is like the rest of your wrist. So it's the bigger bone that's right below your thumb. So this is my radius. And this is my ulna, the one that has that little poking out thing. Then we have types of whorls. These are easier, so I will make you know these. So draw a line between two deltas. So if I find the deltas, like here's one, and this one got kind of cut off, but it's right over here. So if I draw a line between the two deltas in a plane central pocket whorl, if some of the curved ridges touch a line, then it's a plane whorl. If none of the center core touches the line, then it's a central pocket. So here's what I mean. So see how here's the core, right? And here's all the circles around it. And then we have our deltas. So as I go from this delta and I cross all the way over to this delta, I'm crossing some of those ridges. I'm crossing some of the whorl pattern, right? So since I'm crossing some of them, that makes it a plane whorl. Whereas if I have a delta here and the other delta's over here, so I'm going, I'm like, crossing it. But really the whorl part doesn't start till way up here. This is where the actual tight circle is. That's a central pocket whorl. So when I go from delta to delta and I don't cross paths with any of the tight circle, really just central pocket whorls are up higher. But that is how you know for sure, is you draw a line from delta to delta. If it doesn't cross a circle pattern from the whorl, then it's a central pocket whorl. Then we have double loop whorls, which have always confuzzled me as to why they're called double loop whorl, because really they're just double loops, but they call them a double loop whorl. But if I'm looking, see here, we got a loop going in one side and out the same side, And then on the other side, we have another loop in one side coming out the same side. So it's just 2 loops, and they call it a double loop whirl. And then the accidental whirl does not clearly fall under any of the other categories. So it's kind of what I think of how it looks like. It's just like a really squashed looking whirl. And then you call that the accidental whirl because it just doesn't fit exactly up high. Sometimes you're passing some of the circles, but you're like, maybe you're just barely crossing it. So you're not really thinking it's plane. It's kind of squashed here. So it's like more square instead of more circle. So it's just an odd looking whirl. Here's just some examples of some of the pictures. So you see this accidental whirl where it's like, I mean, it is connected. It is this loop, but it definitely doesn't look like the pretty whirl that we're expecting to see. And then we have the double loops. There's a loop. There's a loop. So we're having those 2 loops. And then the deltas here and here. So the central pocket, meaning that if I'm going from delta to delta, I didn't cross any of the circles. But in this one, I go from delta to delta, and I do cross over some of the circular pattern. Then our plane arc, and then our just more tinted arc, just kind of showing the examples. Now, if we have this here, so what's that? This is our left hand. So if it's going in this way and coming out the same side, so going back to the left on your left hand, it's a radial loop. If I have the same hand, but it's going in from the right on the left hand and going out the right, that's also a loop. Okay, so let's identify each of these fingerprint patterns. So this is a whirl. This is an arc. Kind of has a tinted, but then it kind of doesn't up here. This is a loop. It's a little harder to see, but if you're tracking it, we got this loop here going in and out. Some people get confused and say it's an arc because they see this pointy thing, but in reality, that's a delta. So remember, our delta frames the loop, and they frame the whirls. Like this is a delta, little triangle. It's framing it. Here's another the triangle delta shape, framing the whirl. A loop only has one delta framing that loop on that one side, whereas this has no loops. It's literally just up and down, so that's an actual arc. So whirl, arc, loop. This, I have a loop going this way and a loop going this way. So that's a double loop whirl. And then if I'm comparing the two of this would be more tinted arc, and this would be just a plain arc, but I probably wouldn't count you wrong if you said both were plain because this only has that one pointed part. All right, and then we get to minutia. So minutia is just like finding the like little tiny pieces of patterns in the fingerprint. That is how we actually match fingerprints in a crime scene. So while looking at a basic fingerprint patterns, they can quickly eliminate a suspect in order to positively match a print found at a crime scene to an individual. More information is needed. So while looking at basic fingerprint patterns, we usually be like, oh, that doesn't match. Oh, that doesn't match. But when we're getting down to the nitty gritty and you're like, I think they match. There's only so many ways to make up a fingerprint. So there's going to be prints that look similar, but are not the exact same. And it has to be the exact same or it's not the person. So we'll be able to like count out a lot of prints saying like, oh, that's nothing like it, nothing like it, nothing like it. But then you're like, these are similar, but now I'm going to have to really take my time and match point by point. And the points you're going to be matching are called minutia. So every individual, including twins, even identical twins, has a unique fingerprint. Because again, how fingerprints are made is kind of random. Just during your 10th week of pregnancy, when you're being grown as a fetus, your basal layer starts growing and crumpling in weird ways underneath your skin layer. So that is totally random. So all of our prints are unique to ourselves, resulting with unique ridge patterns called minutia. Minutia are points where print ridges come together or end. They are considered to be the uniqueness of the individual. So they're the little points that make everybody's fingerprints unique. Now, the FBI has, and obviously matching fingerprints in lots of cases, has found that no two individuals has more than 8 common minutia. So we haven't found more. I'm not saying that we'll never will, because again, there's only so many ways to make a print. But so far, they have found that people will have matches, like they'll match in 8 spots, but then they'll find something that doesn't match. Then they'll find something that doesn't match. So like you might have someone that has really similar fingerprints. So like it could certainly, you'd want to have a fingerprint when you say it matches at a crime scene. You want to have several people look at it over and over again, really double checking, because you can have points that match, but then find another point that doesn't. And it has to be exactly the same for us to call it a real match. Now, being that we've never found more than 8 to be common minutia, the fingerprint experts use this 12 match guideline. So if you find 12 matches, you can find 12 things on a fingerprint that match, then they're going to say that's a match. Now, they'll probably have more than one person look at it, but that's what we call, like, we're going to say that's our suspect, as if we can find 12 exact match points. So when a fingerprint expert takes a witness stand and says he's absolutely certain 2 fingerprints match, he means he's found at least 12 things that match exactly. So see, these are some of the patterns and their names, what things we look for. I'm never going to make y'all memorize these. I'll always have like a chart with their names next to them, but you are going to need to have more practice finding them. And you'll have to know what a delta is, but I've already showed you that several times. The delta is just that triangle shape. So that one you have to know the name of, and the bifurcation, because that one's really easy to find. So like this is the next one that's super easy to find. And basically everyone's print, I can always find these really fast, as I can find your deltas, and I can find, it looks like a line that splits into 2. So like a fork in the road is what a bifurcation looks like. So that's what I think of as bifork. It looks like a road that's split into 2. So a fork in the road. Those are all over the place. So like here's another one, road splits into 2. So those are called bifurcations. You can also usually find ending ridges pretty fast, because all that means is the line, the black line ended. It just stopped. So like here's one, goes ridge ending, it stopped. The island, so like I have a little space of black surrounded, like it's surrounded by water. It's a little island. So that's what island looks like. Got our delta. A pore is just a dot within a line. The crossover, so is that up here as well? Kind of the same thing as a bridge, but you're seeing like it was a line, and then they like splits into 2 pieces like this. So it will get easier. We'll practice this a couple different times. Like this is probably the hard part about fingerprinting, is trying to find these minutiae to match, but that is what a fingerprint analysis would do, is they're trying to find 12 exact match points. You can also try to quickly narrow down prints and like label prints by their ridge count. So a ridge count is an imaginary line that you draw from the center of the core. So this is the core of my loop to the edge of the delta. So here's my delta. So for my core, draw a line to the delta, and you literally just count how many black ridges you pass. So I counted 1, 2, 3, 4, 5, 6, 7, 8. So you passed 8 ridges. So it has an 8 ridge count. That's it. But they'll classify fingerprints. So like they'll put them in the system by their ridge count. So if we have a suspicious fingerprint found at a crime scene, and we know that its ridge count is 15, well, then I'm going to put inside my database, I only show me fingerprints that have a ridge count of 15. So it just narrows it down faster if you just go by this number and then start trying to look for all these minutia points to match. All right, and that is where I'm stopping.